Continuing our discussion of rational functions, this video is about vertical asymptotes. Equations for vertical asymptotes. If the rational function f of x equals p of x over q of x has been written in reduced form so that p and q have no common factors, the vertical line x equals c is the vertical asymptote for f if and only if c is a real zero of the polynomial q. In other words, f has vertical asymptotes at the x-intercepts of q. Okay, what that means is you need to completely factor your numerator and your denominator, reduce your rational function, and after you do that, whatever makes the denominator zero, that's where you're going to have vertical asymptotes. So let's look at the first one. X squared minus 6. Well, we do have a difference of something that's squared and a number that's not squared. If we were to completely factor this one, we would get something like this. X plus the square root of 6 and x minus the square root of 6. The denominator would actually give us x plus I and x minus I. Now if you don't understand that, it's totally okay. Just set each of these equal to 0 and solve for x. Then you'll see where I got these. Well, what would make this denominator 0? What would make it 0 is x equals positive and negative I. Since these are imaginary numbers, you can't plot imaginary numbers on a Cartesian coordinate system, so this particular function doesn't have any vertical asymptotes. Let's look at the second one. If you were to factor that one, you would get x plus 1, x minus 1, all over this, I believe. There we go. If we reduce it, these two can be reduced. So you get g of x is equal to x plus 1 over x plus 3. So your vertical asymptote will be wherever your denominator is 0. X plus 3 equals 0, which means your vertical asymptote is x equals negative 3. Now I do want you to know that since this reduced, it will create a hole in the graph. This particular graph, if you were to graph it on your graphing calculator, looks something like this. You have a vertical asymptote at x equals negative 3, and then the graph actually goes something like this. Here and here, something like that. However, when you get to where x is equal to 1, there's going to be a hole in the graph right there. So this graph actually does come up like this, but then it skips a space, and then it continues on its way. This hole was created because x also cannot be this 1 value.